Hi, welcome to this video. In this video, I will be showing you guys two examples on solving trig equations that are a bit more complicated than the examples that I've shown you guys in the previous videos. Okay, so I have two examples and they are a bit more advanced. So let's just get started. So here I have to solve this equation where sine 2x, right, sine of 2x is equal to root 2 over 2, and my x has to be within this 0 to 360 degrees boundary. So there are two. There's one thing that's new here. We've never came across solving trig equations involving this sine of 2x. Typically, it is always something like sine x is equal to root 2 over 2, and then we just solve for x. But that's not the case anymore. We have a coefficient in front of my x, which is 2. So that kind of changes everything a little bit. Okay? Now, but if you think about it, let's use common sense. The boundary that I have here, over here, that's for my x. If I have 2x, what do you think the lower and upper bound will be changed? How do you think that will be changed? So if I multiply this by 2, everything should multiply by 2. Make sense? Right? Everything should be multiplied by 2. So 0 times 2, I still have 0. 360 degrees, I will have 720 degrees. So now, the boundary, I have just modified the boundary to fit the 2x that I have there. And how does that help us? Let me show you. So let's say if I say w is equal to 2x, right? Which means sine of w is equal to root 2 over 2. I've just changed this to w, and with my boundary, which is the new boundary that I have there, that would also be changed, where I will have 0 is less than or equal to w less than or equal to 720. And right now, this looks pretty much, the format that we have right now looks pretty much the same as the examples that we did earlier, right? So my w, if you remember your trig ratios, my w is gonna be, it could be 45 degrees, it could be 245, is it? If you're not sure, go ahead and sketch. Just make a sketch. Right? So I have 45 degrees. That's gonna give me a sine value, which is my y. This is 45 degrees. So my other angle that will have the same y value would be here, and that would be 180 minus 45. So that's 135 degrees. Okay, and both of these angles satisfy this satisfy the boundary here. So they're both good, and in fact we can start turning them now. So if I add a 360, I will get 360. I'll get 405 degrees, right? I'll get a 360. I'll get that. If I add a 360, I will get 436. So 495 degrees. And can I add more? Let's see. So if I add another 360, I will get 765 degrees. And if I add another 360 here, I will get 36. So that'll be 555 degrees. No, sorry, 736. So that'll be 855 degrees. I think I'm doing all this in my head, so let me just double check. I'm gonna pause the video and double check it. Yep, I just used the calculator, and all the values here are correct. However, not all of them would be the solution, right? Because as you can see, 365 and 765 and 855, they are here. Sorry, they are bigger than 720. In other words, they are on the right hand side of 720 on the number line. So these two angles will not be our solutions. Cool. So for now we have 4 solutions for my w, but the equation wants us to find x, not w. So this is when I'm going to substitute this back substitute the 2x back. So I get 2x is equal to 45 degrees, or 135 degrees, or 405 degrees, or 495 degrees. So my x, I'm going to divide everything by 2, My x will be 22.5. This will be 64.5. Is it 64? No, 62.5, sorry. 62.5. That would be, what's this going to be? 405 divided by 2, I get 202.5, and I will get 247.5. So my x values are 22.5, 62.5, 202.5, and 247.5. Is that right? No, 22. Oh, this is not right. This is 60. That is actually 67.5. Okay, that's it. So let's take a look at, let's do a quick recap on what we have just done, because the equation that they want us to solve is not just x. We actually have a coefficient in the front, so we're gonna change our boundary a little bit by just make it, you know, the boundary given right now is x, but I'm gonna make it to look exactly the same as what I have there. So, and then by doing that, I'm going to multiply everything by 2. So I'll have a new boundary. That the new boundary applies to my 2x. And after that, I introduce a new variable, w to represent 2x. And then I can change the original equation to look like that. And also the boundary now applies to my w. And then I'm just going to solve it as how we have been solving trig equations that I showed you guys in the previous videos. And I figured out these are the possible values for my w, but we're not asking for w, we're trying to solve for x. And this is when I introduce the 2x back into my w, and then to get this equation. And then to find x, I just divide everything by the 2. Okay? Feel free to rewind this example. If you guys got this, then let's move on. Okay. So here they want us to solve the equation 2 sine square x plus 5 sine x minus 3 is equal to 0. So this is more complex, right? This equation that we have to solve is more complex than the ones that we have came across in the previous videos. So now let's take a look. Let's see what the limitation is. I forgot to put down the limitation. Your angle of x must be between 0 and 2 pi. Okay, so whatever your answer is, your x must be between 0 to 2 pi. So, first of all, do you think we need to change? Do you think we have to change, say, changes to 2x or like 3x or whatever? What do you think? So I have x, this is just x. This would be x as well. This is sine x, the whole thing squared. So, nope, there is no need, right? There's no need for us to change the boundary. Okay, so there's no need. We don't have to do this. The boundary is good. This is fine. Now, so the boundary is good. What about the equations then itself? The equation is a bit tricky. We have never tried to solve trig equations where the power is higher than 1. This trig equation has a power of 2. So how do I approach this? Similarly, I'm going to introduce, say, w. Let me just use a different alphabet. Let's say u is equal to sine x. I'm going to use u to represent sine x. Okay, and let's see what happens. So 2 sine squared, this means the same thing as 2 sine x squared. Okay, so that becomes 2 times u squared, right? Plus 5 times u minus 3 is equal to 0. And maybe, I hope, we can factor it. So I'll have 2u here, I'll have u over there, I'll have a 3 here, 1 there, and I need a plus. So 2u minus 1, u plus 3 is equal to 0. So we will need your factoring skills for this one, yeah? So now it's easy. So I have 2u plus minus 1 is equal to 0. U plus 3 is equal to 0. So 2u is equal to 1. U is equal to half. Or I can have u is equal to negative 3. Yay, we have just solved for our u. But again, the question is not asking us to solve for u because u was something that we introduced. So let's try to convert back to x. My u represents sine x. So I'm going to say sine x is equal to half. And here, sine x is equal to negative 3. Okay? So this is the time where we need to know where you need to remember the trig ratios, right? So sine x represents my y coordinate. My y coordinate, so one of them is here. This is going to be half. Another one is going to be there. Okay? So both of these angles will give me a y value of half. The first angle, and be careful, we're talking about radians here, right? If you look at the boundary, the angle is in radians, so that will be pi over 6. Okay, so x has to be pi over 6, or the other one is, this is pi over 6, this is pi over 6, and the other one is this one, this whole part. That will be pi over 5 pi over 6. If you use your unit circle, I hope not, but if you have to, you can take your unit circle out. Hopefully you understand how I got this 5 pi over 6 without using the unit circle. Yeah. So this is 5 pi over 6, and that's it. Right? That's it. Now let's look at this part. Sine x is equal to negative 3. So if you think about it, on the unit circle, my sine value gives me the y coordinate. And since my unit circle has a radius of 1, is it possible for me to get something like a negative 3 here? Is that possible? My radius is 1, so we can't. So there's no solution here. So for x, sine x equals negative 3, there's no solution. So there's no way we can get any answer out of this. So we can just simply say no solution. Okay, no solution for this. Now let's check if my pi over 6 and 5 pi over 6, are they within this 0 to x, 0 to 2 pi boundary? And they are, right? They are within the boundary. So my x could be pi over 6, and it could also be 5 pi over 6. All right. Again, please feel free to rewind the videos. Okay. Questions like this are pretty common, and we need to know how to do them. Okay. We need to know how to solve them. Let's just do a quick recap for this one. First, we check if anything needs to be done with the boundary. In this case, everything is sine x, so there's no need. Whereas in the previous example, we had to mess around with the boundary because we have a 2x there, right? Now, so boundary is good. Then I introduce a new variable to represent sine x. So I can simplify the trig equation, which looks pretty ugly. I can simplify the way it looks to look like a quadratic over here. And after that, I just apply factoring, right? And factoring, I solve it. I solve the possible values of u. I have two possible values, and then I introduce the sine x back, and then I solve them as how we have been solving trig ratios. Whereas for this u equals to -3, we can't get anything that is less than -1 or more than 1. So there's no solution to this part. Even though there's no solution, you have to show this, okay? You have to write no solution because that shows that you understand that it's not possible to get a solution from there. And then finally, with the two angles that we solved, we just double check it with the boundary, and if that satisfies but the boundary, then it's good. Alright, hope you guys found this video helpful. I'll see you in the next video. Bye bye.